Hi children, my name is Naresh. I am the physics faculty in Pragati Vidyaniketan. So, in our day-to-day life we observe the changes in seasons and tides in sea and during sunrise and sunset. These all things we observe in day-to-day life. Have you ever thought what is the cause behind this? In ancient days, the people are thought that an invisible force is acting behind these reason, behind these causes, and invisible force is acting. Not only in ancient days, nowadays also people think like that only. So later the concept was developed, but it was limited to explain the limited efforts and actions. So not only these three things we observe while you are riding a bicycle. When you are riding a bicycle, most of the time your leg push the pedals downward. Your leg push the pedals in downward direction. Push. Here we observe one word, that is the push. That is the push. Due to this pushing action, you have to make an effort on the pedals. Then automatically the cycle moving in forward direction. When you open the door, you make an effort to pull or push. To pull or push means when you pull the door. When you pull the door means how can you do that? You have to make an effort on the doorknob with your hands. To pull, automatically the door will open. To push means automatically the door is in moving away from you. So here we observe two words. One is the push or pull. So mainly we are focusing on in these all cases till we have discussed. In all those cases we observe only two words. One is the push or pull. What is the push? What is the pull? Push and pull. You can remember these two words, push or pull. Next, pick the stones. Pick the stone means here we observe pulling. And a paper boy throws a newspaper. A paper boy throws a newspaper means he pulling. Okay, so here we observe either push or pull. The next, stretching a rubber band. Stretching a rubber band means this is stretching. Stretching is nothing but that is the pulling. The next, pulling a rickshaw. Here also we observe one word, that is the pulling. Rowing a boat. In these all cases we have to make an effort. Some actions we observe, some actions in our day-to-day life we observe. One is picking and squeezing, twisting and stretching, lowering and lifting. For example, if you want to lift your bag, what you have to do? If you want to lift your bag means you have to make an effort on the bag with your hand by pulling action or lift upward direction. So in these not only here, if you want to, for example, you want to throw a ball towards the wall, you have to make an effort on the ball also to move away from you. So in these all cases we observe that in these all we are putting some efforts on the objects. Automatically we observe two things. One is the either push or pull. So here in these all cases we observe push and pull. So this push or pull are said to be in our physics, that is the force. What is the force means? Force is nothing but push or pull is said to be force. So today we are going to discuss, our topic is force. force means force is nothing but that is the pull or push is said to be force. So in this lesson we are going to learn, this is the mind map in this lesson. One is the, in this lesson first we are going to learn contact force and field force. Field force is nothing but force at a distance. Under the contact force, we are going to learn, first one is the muscular force, and second one is the normal force, and tensional force, One is the muscular force, second one is the normal force, and third one is tensional force, and fourth one is frictional force. And next, what is the field force? In this lesson, we are going to learn under the field force. One is the magnetic force, gravitational force, electrostatic force, and what are the effects and what is the pressure and applications. This is a mind map about this. This is a mind map of this lesson. In this today we are going to learn these are contact force and field force. In this contact force, today we are going to discuss muscular force, normal force, tensional force, frictional force, and field force means this is a magnetic force, gravitational force, electrostatic force by an activities. In this lesson, the first activity is identify push or pull. In your textbook, one diagram given. In the diagram, we observe digging bore well. Here we observe both push or pull. And second one is sipping juice with straw. This is with straw means we are pulling. Here we observe pulling action. Next, erasing blackboard. Erasing blackboard means this is either push or pull. These two comes. So push or pull we observe in this action. Next, a magnet attracting nails. A magnet attracting nails means this is a magnet. Magnet has two poles, north and south. Already you know that in sixth class. In sixth class you got the magnetic force. Here these are all nails. So nails are attracted towards the magnet. So this is the pulling action. Fruits falling from tree. This is the tree here. So fruits falling from tree. This is the pulling force acting by the earth. And hoisting a flag. Hoisting a flag means this is also pulling action. So this is the first activity in your textbook. So based on these actions we observe mainly push or pull. So what is the push, what is the pull? Already we know that pushing or pulling, these two are said to be force.
Lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who is standing on the other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate. When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk here at point A. A person wants to move this desk from point A to this point B. Again, how will he do that? Here, he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some object from the table, we say that you applied a force on that object. Here, the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here, pedaling is the force that we apply on a bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening a drawer, plucking the string of a guitar, moving a piece on a chessboard are some of the other actions performed on objects. So performing these actions on objects is nothing but applying force on them. But these are just a handful of simply too many actions that we can perform on the objects. And it's not possible to write each one of those. But we can categorize all these actions into two basic ones. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we open this drawer, we are simply pulling the knob of the drawer to open it. Similarly, when we are drawing or lifting a bucket of water from the well, we are pulling the bucket towards us. What are the actions that can be described under pushing? Actions such as passing the ball, hitting the hammer on the nail, etc. can be thought of as pushing an object. Are there any actions that can be described under both? Yes, there are. Suppose there's a book on the table, you can either pull it towards you like this or push it away from you like this. So moving an object can be described under both. Similarly, opening or shutting a door can be thought of as both. So we can safely say at this point that the forces are nothing but the push or pull applied on objects. Forces are due to interaction between the bodies or objects. What does it mean? Let's go back to our first example of this video. Here, in order to pass the ball to his teammate, the player must move it. That is, he must...
The object. When the object is slips off from your hand, automatically it moves towards the earth. Because of here the earth make an effort on the pen by pulling action. So, and not only this one, when you throw a ball upward direction, when you throw a object upward direction, it again comes forward direction. It again comes downward direction. Because of here also the earth make an effort. Make an effort means the earth applying a force on the object due to the pulling action. So here in your textbook, in your 8th class textbook, for understanding this force classified into two. One is the contact force, another one is the field force. Field force is nothing but force at a distance. So for understanding that contact force, for understanding the contact force and field force, they give two examples. So one example is when we press the tube. This is the tube. When we press the tube, automatically the paste coming outside. So when we press we want to press the tube means compulsory we have your hand making contact with the tube. So automatically here we observe we are applying force when we have to make contact with the paste, And in 6th class, you got you have seen that magnetic compass. This is a magnetic compass. In this magnetic compass, magnetized needle will be present. When we bring magnet very close to the magnetic compass, automatically this magnetized needle shows deflections. Here, in this first case, our hand making contact with the tube, and in this second case, here there is no contact between this magnet and magnetic compass. Here we observe deflections in needle. Here in first case we observe when we press the tube, automatically the paste coming outside. In first case we observe your hand get in contact with the paste means your hand also considered as an object. That tube also considered as a object. When two objects are getting contact, then when we observe, then there exists one force. That force is said to be contact force. Here we are applying a force. By your muscles of your body. So this type of force is said to be muscular force. And the second case, here we observe there is no contact between two objects, even though one force is exists between them. That force is said to be field force. So one is the contact force. In a contact force, the force there exists when two objects need to be getting contact. So that is the contact force. Here the force there exists when need not to be getting contact to objects is said to be field force. So in this contact force we are going to learn the first one is muscular force. Muscular force. For understanding muscular force, I will show one activity. I will show one video. And normal force. This is muscular force, normal force, and tension force, and frictional force. For understanding these forces, I will show videos. By the videos we can understand very easily these muscular force, normal force, and tension force, friction force also. Briefly, first I will explain here. Muscular force means the force which is exerted by our muscles. That type of force is said to be muscular force. And normal force means, for example, this is a table. So you keep one book on the table. Here, the book here. If the table is absent, if the table is suddenly disappear, what happens to that? If the table is suddenly disappear, the book falls downward direction. If the table is present, the table gives support to the book. So here the table exerts a force on the book normally. This type of force is said to be normal force. Here the book experience one pulling force towards earth due to the gravitation force. Here the book experience another force by the table, that is the normal force. And tension force. What is the tension force? So take one string and take one stone. That stone attaches to the string and suspend it to the support. Then if the string suddenly cut, what happens to that? The stone falls downward direction. But here that is not happening here, because of here the stone experience pulling action towards the earth due to the gravitational force, due to the pulling force of the earth, even though the stone cannot falls downward direction. Because of here the string gives a support to the stone. The string gives a support to the stone means automatically the string also exert a force on the stone. Upward direction. So the force which is exert in a string, that force is said to be tensional force. We can observe the tensional force not only string, we can observe in rubber bands, in ropes also. And what is the frictional force? Frictional force means here, for example, when you push the book, When you push the book, automatically the book forward direction. The book moving forward direction. Not only here, you take one ball, make a ball, roll on the ground. After some time, what you observe, the ball slowly, the ball comes into the rest. Because of here, the earth exists the earth exerts a force on the ball. The ball is moving forward direction. Here, the earth is always oppose the motion of the body. Here, the ball is moving over the earth's surface. Here, one body moving over the other surface, then there may develop an opposing force between them. The type of force is said to be frictional force. The type of force is said to be frictional force. Here, field force. For understanding field force, already I said in mind map. One is the magnetic force, another one is the electrostatic force, and gravitational force, and these all we have to learn by the videos.
We can talk of is the force of friction. What is force of friction? Try rolling the ball on a horizontal plane surface. What do you notice? You noticed that this ball gradually slows down after some time and eventually comes to a halt. Why does this happen? Why doesn't the ball continue to move in the same direction forever? The reason for its slowing down and ultimately stopping is the force that this surface applies on the ball when it's moving. Yes, the surface applies the force on the ball, and the direction of this force is opposite to that of the motion. So when the ball was traveling towards the right, the surface was applying a force on it towards the left. The force applied on the ball by the surface is called the force of friction, or simply friction. Friction plays quite an important role in our daily life. We can walk and run because of
muscular force. When we push an object such as a box or lift a bucket of water, then the force is caused by the action of muscles in our body. This force is known as muscular force. Note that muscular force is always applied either directly through touch or indirectly with the help of a stick or piece of rope. For examples, cutting the vegetable or fruits with the help of knife, hammering of nail with the help of hammer, pulling a cart by horse.
Gently push a book on a table. What do you observe? Well, you observe that it stops after moving for some distance. Now repeat this activity, pushing the textbook from the opposite direction. Does the book stop this time too? Can we say that a force must be acting on the book, opposing its motion? Well, this force is called the force of friction. You saw that if you apply the force along the left, friction acts along the right. If you apply the force along the right, the friction acts along the left direction. In both the cases, the force opposes the motion of the book. In fact, the force of friction always opposes the applied force. In the above activity, the force of friction acts between the surface of the book and the surface of the table. The friction is not the same for all the surfaces. It depends on the smoothness of the surfaces.
Stone is suspended with the help of a thread or string, and its free end is tied to the retort stand. We know that the stone would fall down due to gravitational pull or weight of the earth if the string is broken. For a stone tied to the thread, gravity pulls down the stone all the time, but it does not fall down because it is supported by the thread. Thus, there exists a force which supports the stone against gravity by pulling it upward. It is called tension, which always pulls the bodies along the string. The direction of the tension force is always away from the surface of the object to which the thread is attached. When we try to stretch a thread or a string, the tightness of the thread or string is called tension. In the above example, the gravitational force is balanced by the upward tension force.
Now we can consider the normal force. So our first question is, what do we mean by normal force? Let's start with one word at a time. Force, we've already talked about, is a push or pull on an object. So then we get to normal. Now what we don't mean by this is it's not an ordinary force. While they happen all the time, that's not the usage of the word normal we mean. Instead, we're talking about a mathematical definition of normal that refers to the perpendicular. So for example, if I have a surface, my normal force is always going to be at a 90-degree angle perpendicular straight out from that surface. And I use the F with a sub n as my symbol for it, both capital F and capital N. So here's some examples. Again, if I have a horizontal surface, my normal force might be straight up from that surface. If I have a vertical surface, my perpendicular is going to be, say, out to the left. And if I have a sloped surface, my normal force is still going to be perpendicular, but that means it's going to be off at an angle. Now, when do you have the normal force? Anytime you have solid surfaces in contact with each other. The normal force is the force that prevents those solid objects from going through each other. Now, from Newton's third law, we know that forces come in pairs. So let's understand that in terms of a normal force. The ground pushes up on the block with a normal force, but the block also pushes down on the ground. If I push on the wall to the right, the wall pushes back on me to the left. These are force pairs. I push on it, it pushes back on me. In both cases, I can't push through the wall and the wall doesn't push through me.
Take two balloons and suspend one of them in the air by means of thread. Hold the other balloon by a thread tied to its end and bring it near the other balloon which is suspended. What do you notice? Do you see any force between them? Nothing in particular. Now rub the free balloon which is in your hand with a woolen cloth for some time. After that, bring it again near the suspended balloon. Do you see anything strange now? Yes, both the balloons seem to be coming towards each other. We can say that they are attracting each other. Why is this happening now? It's happening because of the force that acts between them. The force is attractive in nature. But this attractive force was not present initially before rubbing. Something must have happened to this balloon after we rubbed it with the woolen cloth. We can say that this balloon acquired something from the cloth after rubbing. And that something is what we call electrostatic charge. Let me repeat. When we rubbed the balloon with the woolen cloth, it acquired some charge. So this balloon is charged now, and this charge is responsible for the force of attraction between the two balloons. What about the suspended balloon? We call it the uncharged balloon since it has no charge. It doesn't have any charge as we haven't rubbed it with anything. Now rub the suspended balloon also with the woolen cloth. It will also be charged. So we have two charged balloons now. Bring them together. What did you see now? Both the balloons are moving away from each other now. That is, they are repelling each other. Again, they are repelling each other because of the force that is acting between them. But here, the force is repulsive in nature. What can we conclude from these two experiments? In the first case, there was a force of attraction between the charged and the uncharged body. And the second case, there was a force of repulsion between both the charged bodies. In fact, whenever we rubbed two bodies together, both of them acquire charge. Then this charge attracts or repels other charged or uncharged bodies when brought near them. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. The electrostatic force can be either attractive or repulsive in nature.